Hello everyone, welcome to this session. After the previous sessions, we have talked about how GA works. So from this session, we will talk about how to implement GA. We will use a way to call the MATLAB GA function. By calling this function, the GA will be implemented. So before introducing this function, we first talk about the MATLAB global optimization toolbox, because GA function belongs to this toolbox. So GA optimization, global optimization toolbox provides a series of functions. The same goal is for global optimization. So as we have said, global optimization algorithms doesn't guarantee we obtain the global optimal solution, but instead we are aiming to do that, right? So also all these functions in this toolbox, we can handle constraints. So it can handle unconstrained or constrained global optimization problems. And all these problems are considered to be minimization problems. So here I provided two hyperlinks, and when clicking them, you can find out more about this toolbox. Then, what algorithms are there in this toolbox? So here are they. We have the direct search, the GA, the particle swarm optimization, which we will introduce in the next week. And they also have the surrogate model optimization and simulated annealing and multi-objective optimization. They use an algorithm called NSGA2. So this is also based on GA. So some of these will be taught not in this specialization, in the next one, the advanced one. So now let's see the GA function. We first see simplest form. X is the output equals to GA parentheses function n-vars, right? So let's first make a few comments about this function. First, this function carries out minimization, as I've said before. So if your function is for maximization, then how to do? You just put a minus sign above your objective function, then the maximization becomes minimization, right? And also when using this simple format, the constraint won't be considered. There's no constraint set here. And also more importantly, there's no search bound. And the search bound is always available in real-world optimization problems. So if we don't set it, it uses a default search bound. If it's continuous variables, the default search bound is -10 to +10. If they are integer variables, the default bound is minus 10,001 to 10,001. Now let's see the input and output. Let's first see the output X. So this X is an optimal solution or optimal decision variables after GA optimization. The X is here. So function is what? Is the objective function for minimization. NVARS is a number of variables of the decision variables of the function here, right? So this is the simplest form of the GA function, and we can see it's using this format. But clearly this has some problems. The biggest problem is that it can't set the search bound. So if you want to set the search bound, you can use a bit more complex format. So we can see like this, LBUB. And you can see before LBUB, there are 4 empty square brackets. So what are they? So these ones are for inequality and equality linear constraints. So the LB and UB to set the search bounds. So these are the things we have discussed. So I will repeat it here. LB is the lower bound of the decision variables, and the UB is the upper bound of decision variables. So we can define them here. So they can be the vectors, right? And if you want to define some options, you can do it. You can write the options here. So options are what? We put the optimization settings. So for example, the population size, the crossover rate, so these kind of things, and we can set the plot things in the options. But pay attention that before options, there's also a empty square brackets. And what is this for? This is for the nonlinear constraints, right? So if we want to put options, don't forget this one must be there, right? Otherwise, you have the nonlinear constraints, you can put it here. Okay. Then we can see that what is options. So first options is a struct. This struct contains optimization options. So we can use this function like optim options function to set it. So for example, this is GA, and I want to plot the convergence curve. I can say plot func GA plot best F. So when we use this, when I run the GA, the convergence curve will be plotted. And sometimes we can, when some of the variables are integer, you can use this one, int count. So see this location also after these empty square brackets or the nonlinear constraints, right? So we can see the int count, it indicates the index of the design variables that listed in int count. This will be integer values. So for example, you want your second variable to be an integer, and you can write 2 here, right? So this means the second will be the integer. So these are the input, and we can see an output. So FVL. So what is FVL? FVL is the objective function of the optimal solution X, right? So if we have two outputs, both the optimal variable X and as well as objective function will be displayed here. And also notice on this side, if we want to use both int count and options, the sequence is like this, right? So for more details about how to add constraints, so you can follow these hyperlinks to look at this function, and there are also examples there. Okay, that is all for this session. Thank you very much. Bye-bye.